Hello and welcome back to Ada Pulse, the community-funded news channel keeping you up to date with everything Cardano. And because we are community-funded, there is no coin shilling, there is no paper motion, we don't even discuss token price. We are just here to disseminate information. Today on Exploring Cardano, I talk to Niles, the developer behind Eopsin, a smart contract language that allows you to build smart contracts in Python, which is making the developer experience substantially easier for smart contracts on Cardano. In today's discussion, we talk smart contracts, Python, open source, and you'll even get to see me struggle at writing some of the simplest Python code. I hope you enjoy. Can you sort of walk us through your experience and background and how you first became interested and involved with the Cardano ecosystem?
So, I can start with my name maybe first. I'm Niels. I am trained computer scientist. I'm more or less just generic computer science, and focusing actually on verification and security in systems. And I think that's what drew me to Cardano initially, because I think from its design, it's very solid, it's very stable, it's very well thought through. Also from, let's say, a mathematical perspective, it's very elegant, and that's kind of just attractive. And then it had some quite interesting problems, mathematically speaking. So, like, how do you write programs on this that in a language that people kind of understand, but compiling it into the language that's secure, that's the base of Haskell, the base of Cardano, which is Haskell, or just like the functional programming ideas that are behind Haskell.
Mm-hmm. Yeah, and I think I'm incredibly interested in the project. I'm a developer myself, but I work on big data, so I mainly use Python and R, and trying to learn some sort of Cardano development, trying to learn Plutus. It's a completely different world for me.
Yes,
so when I heard someone was actually working on this for Python, yeah, definitely piqued my interest. So let's dive into Eopsin. So can you give us sort of a brief description of what it is and sort of what it aims to solve?
So Eopsin is a programming language that lets you write the on-chain part of smart contract, the apps on Cardano. So on Cardano, usually, maybe to give you a bit broader overview, a DApp usually consists of on-chain code and off-chain code. That's different to EVM chains where the contract can handle almost everything. In Cardano, the contract is just there to verify that things are going right, and then off-chain code takes care of all the other stuff, and that's good because you can kind of live upgrade off-chain code, you can fix bugs, and the contract will just always check that whatever you have done will still adhere to what you what was your initial intention. So you cannot upgrade the contract, but the contract kind of only has very simple primitives that say, okay, you're allowed to spend these transactions, you're allowed to mint these tokens, and these kinds of things. And Eopsin, so previously there was PyCardano, which lets you write the off-chain part in Python. And then you had to kind of interface that with Haskell code, with the Plutus code, which is very unintuitive if you are coming from the Python world. So yeah, Eopsin is filling that gap. Now you can write these validators, these on-chain smart contracts, in Python, and it's designed so that it looks like Python. It's not actually, it's not the same. You cannot. Not every Python program is a smart contract, but if it's a smart, let's put it like this, Eopsin looks like Python, and it behaves like Python. So you don't really need to care about the fact that it's not actually Python. It's just, for all that matters for you, it's Python. And you just can't do everything that you can do in actual Python, and we don't want to do everything because Python has some weird features that we don't really want to have on-chain, but if you don't use that, then you don't have to really care about this fact.
So it's basically a subset of Python.
Exactly. It's a subset of Python, and it's a secure subset, which I think is very important, because a lot of criticism has come that, Python, Haskell has been chosen because it's supposedly such a secure language, and why do we now use Python? And the idea of Eopsin is, okay, we restrict Python to those commands that are actually safe, and that lets you write secure code, but that also is intuitively readable because Python just by design looks very clean and easily understandable.
Yeah,
that's at least my opinion, and I think a lot of developers
I think it's my opinion as well. Yeah. Do you have a demo? Ready for it?
Of course.
Let's dive into some of the details.
So let me first quickly give you the idea of how these contracts are structured. So the contract is one function, and that function is that function validates that certain transaction can be executed. So let's say we have our contract, and now the contract lives at some address, and you can always send funds to this address because it's just another address in the Cardano ecosystem. You can always send funds to some address, right? But once you want to spend these funds, usually you have someone owns the key to the funds, to the address, right? But in the case of the smart contract is the key. So when you want to spend the funds, you ask the smart contract, means you execute that program at the address. And if that contract now says, oh, yeah, that's fine, you can spend these funds, then you can take them. And that gives you the control over what can happen to funds at this address. So, for example, for DEXs, you have that address that manages the pool funds. And then that contract makes sure that all the constant products, formulas, and everything is maintained. Or for staking, you have an address that just checks, okay, the signer of the original message now withdraws again, and no one else can withdraw. Something like this.
Mm-hmm.
Okay, so I'm using PyCharm because it's just, I think, objectively the best development. But I'm not paid to say this. It just makes development very easy.
Yeah.
So what we have open now is the example validator contract. And let's ignore these lines and just look at how it looks like. And what you can see is that we have this one function validator, and that's where Eopsin, where the subset already starts. Eopsin forces you to have this one function that's called validator, and it has to be in your code. And another thing that Eopsin forces you to do is to annotate everything with types, because what Eopsin does is tries to guess the type of everything in your code, and if it doesn't manage to to guess the types, then it says, no, I won't compile this into a smart contract because I consider it unsafe.
Mm-hmm.
And this conveniently also allows for some optimization, so this code is actually at least on par and often even faster than the Plutus code.
Mm-hmm.
Okay, that's some technical details. So let's look at the signature. We have the validator function, and that takes 3 arguments. The first one is a datum. So if you currently in Plutus v2, if you lock funds at some address, you attach a datum. And that datum contains information like, okay, this signature is required to unlock this, or this is part of a pool with these parameters, or something like this. And this has some Plutus data type. Plutus data is just static information, and you can define it just like this in your code. And then we can, for example, datum.pubkey hash access parameters that are locked with the initial name. Redeemers, in this case, it's nothing, but you can imagine that any datum is, let's say, we can also attach the same datum as a redeemer. The functionality of a redeemer is something you want to spend the funds. Now you attach a redeemer to your transaction and say, okay, maybe the signature that's allowed to withdraw this is the third one, and then you attach a 3 as a redeemer. So some simple idea. Or we can imagine that here we actually, in the cancel datum, we have a list of pubkey hashes that are allowed. And then you can attach an integer redeemer, and that says, okay, I am the first or the second or the third in this list of pubkey hashes, and this one is, then it just checks that this person's actually there. It doesn't have to go through the whole list. And so yeah, just
so you don't actually need a redeemer in.
You don't always need one. Sometimes it improves the efficiency of your code. Sometimes you need one. Yeah. For example, say we have a decentralized exchange. Then the redeemer tells you, I'm trying to swap with the pool, or the redeemer says, I'm trying to add liquidity to the pool, and then the validator does different things based on what you're trying to do. Right, in this case, we just say, okay, the cancel datum contains a list. These hashes, these pubkey hashes are just signatures, right? So these people, basically, these accounts can withdraw money, and the redeemer specifies which one should be allowed to do it. And then we have a context. The context is a very huge datum that's attached, and it's attached by the node. So whenever you spend something, the node just attaches some arbitrary data that's part of the transaction, which we'll need. But the good thing is, we now have a Python IDE. This is all legit Python code, so we can just explore how all this defined. And it's currently defined in the prelude, and you can just squall the source code and see how it works. So in this case, for example, we have script purpose. Usually the purpose is minting, spending, rewarding, certifying, and we are currently trying to spend funds, so that's going to be our purpose. Then the info contains stuff like what are inputs to our transaction, what are outputs to our transaction, how much fee is going to be paid, who signed this transaction, and that one is the interesting one for us right now. So let's go ahead, and I'll give it to you now. What should we write to verify that some signature is present to withdraw these funds?
Sorry, repeat that again.
So this validator, okay, I'll give you one tool, one more tool. You can do something like assert something and then some error message. And if this assertion fails, then the contract will not validate. Otherwise, it will validate.
Right. Okay.
So it's normal Python code. So if it returns something, then it's fine. If it throws an error, then you cannot withdraw funds. And now we want to make sure. So we have someone sent a transaction to the contract and attached a list of pubkey hashes that are allowed to withdraw.
Yep.
And now you want to withdraw with your signature, which is part of this list. And you sign, and your signature is part of the TX info here in the list of signatories.
Right, okay. So we basically got to get the list or the item in that list, and then so do an if on that.
Yeah. If.
So if the script context context dot signatories and which one would I be wanting to check to equal that?
Which of the signatories?
Yeah.
Would
that be the redeemer?
Yeah, we can
Right.
make that the redeemer. So we take the signature at the redeemer position,
Okay. And I want that to equal.
Well, we don't know if it's which position of the cancel datum, but we can do something like it has to be in the datum dot public hashes, right? So, I mean, this is some fancy Python syntax. Just goes through the list and checks that it's in there. But this is allowed. More verbose way would be to say, okay, for b in datum dot public hashes, check that this is actually
Equal
b.
to d. Yeah. And then if that, and then we just return true.
Yeah. So now there's one catch to Eopsin, and that's the only return statement can be at the end. So what we do is just we say, okay, the result is false, and if it's there, then the result is true.
And why is that?
That's part of how the embedding works, and it's a very technical detail, but it's kind of, if you have multiple return statements and you are translating that into a functional language, then you have to do some very elaborate control flow analysis to see where does your embedding stop execution. And so just forcing the return to be the last statement just improves efficiency a lot, and I think it's something that people can handle. If not, I mean, I'm open for feedback. I want this to be a very accessible language. It starts with being in Python, but it might not stop there.
So what's sort of an example of a slightly more complex transaction?
One example would be, for example, token wrapping, which I demonstrated earlier, like a few days ago. So you can see this a bunch of code, but essentially we have the validator again. But here, in this case, the validator and the redeemer don't matter at all. Because what this contract does, you can send some token. Let's say, for example, the milk token of MuesliSwap doesn't have decimal places. So a prime example would be, how can we, in a decentralized way, add decimal places to this? And what we can do is we can use this contract. And this contract allows you to lock tokens at some address. And in return, you can mint 1,000,000 times this token. So essentially, what it gives you is just a pegging of 1 to 1,000,000 between these two tokens. And so here we use, for example, the purpose, because the script is both used for minting and for spending. And if we want to mint the wrapped token, then we check, okay, how many tokens are locked at the address, what's my policy ID, and then we check, in the end, we just check, okay, all the tokens that have been locked minus all the tokens that have been removed from the contract are how many tokens we mint. So we can also burn tokens to get back the original token. And then you see how the validator is really just a short script that validates that everything is fine. How you, in the end, create transactions that mint or burn the tokens is up to you. But that's the elegant design. You can just say, okay, this contract does what you want. It just checks that the pegging will be fine, and then you can create very complex minting tools. You can use this, for example, as part of the batching in an automated market maker scenario. So if someone wants to buy milk and there's only the wrap token in the pool, then you can take the tokens from the pool, send them to the contract address, and mint the wrap token, or burn the wrap token and get back some real milk.
Right, and that would all be sort of outside the smart contract in
exactly.
the back end system.
And, yeah, so part of what you're doing off chain is you're trying to take funds from the AMM contract, which will validate its stuff, and then part of your funds will come from from this token wrapping address, which will validate its funds, and you will gonna mint some tokens, which is also this script, because you can also use these scripts to mint tokens. But yeah, the how the contract is used in the end is totally up to you, and that's, I think, what makes it so dynamic and so flexible.
So how is this different to Plutus, sort of in a general way? Firstly, I mean, obviously it's incredibly easy to read, and it seems to be like a lot shorter as well.
So I'm gonna stop the sharing, I think. So Plutus is embedded in Haskell. Yeah, of course, that's the first difference to here, where we embed in Python. Then Plutus has a very long dependency chain. Here we just have a few Python packages, because Plutus essentially, it depends on the Cardano node, and then you have to build the whole node and everything. And here we just say, okay, we know this compiles to something called untyped Plutus core, which is a fixed set of instructions that the chain knows how to execute. And we just fix them and say, okay, we know how that looks, and then we just compile against it. And so the setup is much faster. So you basically just pip install Eopsin lang, and then you're off to go. There's a few things that this does different to Plutus on a very technical level, in the sense that it doesn't check the types internally. So it does during compilation. It just makes sure your code is fine. But then in the output, what makes Plutus so inefficient partially is that it checks types every time you run the contract, which is just very expensive and a waste, basically, because you check the types already when you started compiling. So what Eopsin does different, and a lot of other projects like Akin also do it that way, is they only check the types when compiling, and then the on-chain code just assumes that the types are right, and it will fail anyways otherwise. So that's how it works.
Yeah, and I think saw earlier this week quite a lot of discussion on Twitter about Icon and how much more optimized it is compared to Plutus, and
exactly.
So I imagine this is probably more optimized than Plutus as well.
Yeah, exactly. So I ran this token wrapping contract, for example, the gift contract, and they are already pretty good. There are some generic UPLC optimizations that you can apply on top of that, which again shaved off like 50%, and then you can do some. I mean, this is Python code, so what I'm planning to do is to add kind of all the optimizations that you can already add to Python code. You can fault constants, but essentially we have all the tool chains that are built on top of Python available here because it's Python code. And that's, I think, what makes this so powerful. I mean, Haskell, the Plutus can also make use of a lot of chain tooling built for Haskell, but just because Python is so dominant in the programming world, I think there's a lot more tooling that we can draw from.
You've got a lot more libraries available to you.
Yeah.
And also sort of helps build into sort of the front end with Django, and if you basically want to develop your whole stack with Python, I think now you can, exactly. which is a great thing.
There's also an example tutorial with PyCardano that shows you how to, because you can actually in PyCardano, in your off-chain code, you can import this contract, and that gives you all these datum definitions that we have defined here. So then in your off-chain code, you can use the actual on-chain code definitions to find out what datum do I have to attach, what redeemer do I have to attach, and these things. You can pre-evaluate the contract locally before you run it on chain to see if it fails.
So am I correct in saying, sort of just a general overview of the different languages, Plutus, Icon, Eopsin, and then the untyped Plutus core is kind of like an assembly language, and then you have these hierarchical languages on top, and you can sort of pick and choose whichever one you want. And it's because I think a lot of people actually get confused when they want to start developing on Cardano, and they think Plutus is it's sort of the only way to create smart contracts, but actually it's sort of a language built on top of Cardano.
Exactly. So, I mean, for a long time, it was actually true that the only way to go was more or less through Plutus. But throughout the last year, there have been a lot of alternatives developed, which is Plutarch, Helios, Eopsin, Icon, and they all serve different purposes. Like Helios is TypeScript. Basically, Eopsin is the Python gap. So if you want to build your stack in Python, you can use Eopsin.
What are some of the challenges that that you've faced when building these tools?
I mean, the biggest challenge I would say was in the beginning to get the idea right, because Plutus Core and Aiken and a lot of languages that build on top of it are actually functional in the sense that what we are doing here, you have one instruction, then you call the next instruction, then the next one, which is how most people learn programming. It's not how these languages work. They just call functions recursively, and that's sometimes a bit unintuitive to get into. Mm-hmm. And so there is a way to translate it, and that's what I've done here in the background, and that's, I think, the hardest part. And now there's going to be some work as well to harden this, to bring this into a state where every part of the toolchain has been checked and tested, so that we don't introduce any issues here. Or one thing I've also been working with is to get the feedback to the developer as well as possible, because what you can do. Wait, let me share my screen. So let me clear this. So you can now call Eopsin just from the command line, and it gives you all the options that you have. And for the contract that we just wrote, gonna do examples, smart contracts, gift, and we want to compile it. So this will compile the Python code into UPLC code. Mm-hmm. And now you actually get an arrow. And this arrow now points you not into my code where I threw some exception, but actually into your code. And it says, okay, the function validator has a different return type than what it's supposed to return. This is one of the static type checks. So actually we did something wrong here. We returned true or false, but we are supposed to return none. Mm-hmm. And so what we will usually do is we assert at the end that what we want to return is true. Mm-hmm. So let's try it again, and now it compiled to something.
No, compile. Right, yeah. So I mean that's a pretty nice error message, and I think that's incredibly important, especially for new developers coming into the space, to have good error feedback, which sadly Haskell doesn't. It's probably one of the most cryptic error languages. You spend most of your time actually trying to figure out what the error message is rather than coding. So yeah, I guess that's another benefit.
So that's why I'm trying to make this as accessible as possible. So right now I'm looking for people that want to build on top of this and give me feedback on what needs to be improved, what works, what doesn't work, and how can, for example, these error messages, which is hard to build tests for because you kind of have to build wrong programs. It's not usually what you do, and I think also part of the reason that Haskell error messages are so cryptic. So. Yeah, I think these are the biggest challenges, but so far it's going pretty well, and I see a lot of traction on Twitter and a lot of interest in the project. A lot of people reaching out to find out how it works and how we can adopt this.
Yeah, that's great. So I guess that leads on to what's the support been like from the community, and what more support do you need?
Um, I think, uh, let's say, I mean, there's always the easiest way of support is just sharing this project and showing it off to your friends, to your colleagues, to whoever you talk to you and told you that they won't develop on Cardano because they don't know Haskell. Then just show them this, and hopefully this will increase adoption of Cardano, of the language, and everything. Then, I mean, of course, there's always the topic of funding. This project is currently not funded, so I'm building this essentially in my free time. And if we want this to be the language and very very user friendly, then there's going to be someone to maintain it, to run tests, to collect feedback, to run errands and all that stuff. So
Are you looking to apply for Catalyst Fund in Fund 10?
I applied for Catalyst Fund. I'm going to apply again. So that's a way to support me, is to just vote for the project on Catalyst, share it during its funding period, and of course there's always the option to directly donate funds. Or if you are a bigger project and want to build on Eopsin, you can always reach out to me, and we can collaborate on the development.
Great. We'll make sure to put those links in the description as well. So I want to talk to you about open source. The whole sort of ethos of Cardano is this sort of open source program for anyone to contribute. But we're seeing more and more in the space, projects like Meld, Charlie 3, Optim, and many others have built their own tooling for Cardano, but are sort of hesitant to release it to the competition. And obviously, I mean, that's understandable. If you put so much time and effort into building your own tooling, you don't want competitors to come in and swipe away. Well, how do you see the relationship between sort of open source development and decentralization playing out in Cardano in the future? And sort of what are some of your ideas on that?
That's a very good question. I hope that, for example, through the use of PyCardano, through the use of Eopsin, I think one of the main issues is that projects building on Cardano currently have to invest huge amounts of money for building and then for auditing their products. And I hope that projects like Akin, projects like Eopsin, are going to reduce these costs, and then also the hurdle to release your code to the community and have more. I mean, also the competition in that sense. But if your code is solid and your community is big, maybe even your community can contribute to what you have built and improve your tooling, then there might be more incentives to open sourcing your tools. So essentially, it's twofold. Once we get tooling that's easier to develop, the hurdle to release your products is lower because you didn't invest so much money. And on the other hand, as the tooling gets more accessible, it's also more interesting to open source your tooling because more people can contribute to it. Imagine everyone who knows a bit of Python can contribute to your batching, to your off-chain, to your on-chain tooling. And then it's actually quite interesting to open source this. Currently, only very high-skilled Haskell developers can contribute to your code and are unlikely to, so maybe the incentive to open source it is not so big.
Yeah, I completely agree with that, and that's why I sort of think the future with all these different languages is quite exciting. So, what in your opinion would be the best learning path for someone with no prior knowledge or coding experience, and they want to become a developer on Cardano and build their own project? There's a lot of things to consider. Firstly, what smart contract language, what backend you're going to use, what front end you're going to use, and sort of where even to begin. So what would you recommend the pathway for that to be?
I would say there's a great website, the developer portal, which features a lot of content specific for Cardano. I can send you the link to that later. I can put it in the description as well. And then, I mean, you should be able to code something. So, I mean, pick your sword, pick your language that suits you best, where you can develop on Cardano, and then first learn that.
Preferably Python.
I mean, yes, Python is very easy to pick up, so I can always recommend using Python. And so you can you learn that maybe also in combination with looking at existing projects. There is Demeter.run, which features a lot of out-of-the-box building examples, tutorials to start building, to look at existing code and to modify it, to play around with it, which is the best way to learn, in my opinion. And yeah, so I would, these three things, I guess. Pick your sword, and then the Cardano specifics and the existing Cardano projects, and learn to kind of wrap your head around how the things work.
Great. What's something that you find exciting in the Cardano space that's going on right now?
So obviously, most exciting part is for me that currently kind of Aiken and Eopsin and Helios are receiving bigger and bigger adoption and traction. So kind of almost at the same time they emerge and show the community that there's so much more on the on-chain parts, and people are realizing that the off-chain parts have been in different languages for a long time already, and are kind of mixing and matching these things. And I'm very curious to see where that goes. People are reaching out, wanting to build on-chain tooling in Go or in other languages. So I think that's going to be quite huge.